So for the last couple weeks of school, we're going to be looking at surface area and volume of three-dimensional figures. So we're going to start with surface area. So since this is the beginning of a chapter, there's lots of vocabulary, and I apologize. But we're looking at surface area of prisms and cylinders. Our objectives: 1, find the surface area of a prism, and 2, find the surface area of a cylinder. So first, our definition for surface area. So the area is basically just the area of the surface of a solid. And the way we find it is we find the sum of the areas of all the surfaces of the figure. And that's basically all it is. Basically, volume and surface area is, as long as you know vocabulary and can look up some equations, you're just plugging stuff into equations. So that's really all it is. So first, let's define our first three-dimensional figure as a prism. All right, so the underlined words, those are vocabulary. So a prism is a polyhedron with two congruent parallel faces, which we call the base, or the bases. The other faces are called the lateral faces, and those are rectangles or squares. You name a prism using the shape of its bases. So like right here, I've got a figure that's got triangles for bases, and then 3 rectangles for the sides. So that means our bases are triangles. These are our bases. And then these are our lateral faces, are the edges and the places in between. And since our base is a triangle, we would call this a triangular prism. All right, the altitude of a prism is a perpendicular segment that joins the planes of the bases. So if we drew a perpendicular segment between the two triangles here, that would be our altitude. The height, h, is the length of the altitude. So it's how long the length is. The length of the altitude, I mean. Okay, so that is a prism. We will be working, I think, mainly with just rectangular prisms, so prisms where your bases are rectangles, and then triangular prisms where your bases are triangles. You can have any shape. You can have a hexagon, you can have an octagon for the base, you can have an octagonal prism, but we did not get a chance to look at how to find the area of regular octagons and regular polygons and stuff like that. So we're going to not worry about those while doing our prisms. Okay, so let's define what a right prism is. So a right prism, in a right prism, the lateral faces are rectangles and the lateral edge is an altitude. So if you look back up at this picture, this line right here, I've labeled as a lateral edge. And that just means that that is a perpendicular line connecting our bases. So it's our altitude. We can also have oblique prisms, and if we have an oblique prism, that means that some or all of our lateral faces are not rectangles. So we don't really deal with oblique prisms. Okay, so lateral area of a prism is the sum of the area of the lateral faces. Surface area is the sum of the lateral area and the area of the two bases. So lateral area and surface area are slightly different. We need lateral area to find surface area, but just finding the lateral area doesn't find our entire surface area. There is a formula for finding surface area of a prism. The surface area, which we label as SA, of a right prism is 2b plus ph, where b is the base area. So if it's a square, length times width, rectangle, length times width. If it's a triangle, 1/2 base times height. P is the perimeter of the base, and h is the height of the prism. So we'll need to find a few things to plug into our formula, but once we have those, it's a pretty straightforward process. All right, example 1. Find the surface area of the prism by answering parts A through D. So we've got our prism down here. It's a triangular prism because our bases are triangles. Now, to find the perimeter of the base, you'll notice we know one side of our base is 3 centimeters and the other side is 4, but we don't know the last part. So we're going to have to do a little bit of calculation to figure out what our perimeter is. You'll notice it's a right triangle because we've got that little right angle sign down there. So let me draw a picture. We got our right triangle. One side is 3 centimeters and the other is 4. We're missing the hypotenuse of our triangle. So we can do Pythagorean theorem. 3 squared plus 4 squared equals x squared. Alright, so 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. And then to get x by itself, we're going to have to take the square root of each side. And we find out that x is 5. So the 3 sides of our figure are 3, 4, and 5. So the perimeter of our base, the perimeter of our triangle, is 3 centimeters plus 4 centimeters plus 5 centimeters, which is 12 centimeters. Alright, so there's the perimeter of our base. Part B says what is the lateral area of the prism. So from our formula was 2b plus perimeter times height, right? Yeah, perimeter times height. So this part right here, the perimeter times height, that is our lateral area. So that's what we're looking for in part B. So in part B, we know our perimeter. Lateral area is perimeter times height. Our lateral area was, our perimeter was 12 centimeters. And then the height of our prism is right here, 6 centimeters. So times 6 centimeters. So 6 times 12 is 72. So our lateral area is 72 centimeters squared. And since we are talking about area, all of our units of measurement are going to be squared. Part C says what is the area of the base in simplest radical form. So our base is a triangle, which means our formula for the base area is 1/2 base times height. 3 and 4 make up the base. Well, the base, I guess we could say, is 4, and then the height would be 3. So this is going to be 1/2 base, which was 4, times height, which is 3. So half of 4 is 2. 2 times 3 is 6. So 6 centimeters squared. And so that way, the surface area of our entire prism is equal to, surface area is 2 times the base, which is 6 centimeters squared, plus perimeter, plus the lateral area, perimeter times, perimeter times the height of the prism. So 2 times 6 plus 72 is 84. So our surface area, 84 centimeters squared. Example 2. Find the surface area of a prism by answering parts A through D. A, what is the perimeter of the base? B, the lateral area of the prism. C, the area of the base. And D, surface area. So basically, same thing we did in the last example, except this time our figure is a rectangular prism instead of a triangular prism. So for this one, we're not going to have to do any extra math to figure out missing sides. So let's look at our base. Down here, we've got a rectangle. It's got a length of 4 centimeters, a height of 3 centimeters. So the perimeter, if you'll remember, formula for perimeter of a rectangle was 2 times the base plus 2 times the height. So 8 plus 6 is 14. 14 centimeters is our perimeter. So our lateral area is perimeter times the height of our prism. We found our perimeter was 14 centimeters, and the height of our prism, if you look at our picture, is over here. It's 5 centimeters. So 14 centimeters times 5 centimeters. 14 times 5 is 70. So lateral area, 70 centimeters squared. Part C, area of the base in simplest radical form. We're working with a rectangle, so the formula for the base area is base times height, so 4 centimeters times 3 centimeters, which is 12 centimeters squared. So the entire surface area of our rectangular prism is 2 times the base, so 2 times 12 centimeters squared, plus the lateral area, which we already found, was 70 centimeters squared. So 2 times 12 plus 70 is 94. So 94 centimeters squared is our surface area. And example 3, find the surface area of the rectangular prism. Same thing we've been doing, except this time it doesn't break it down into 4 different steps. So the things we need to know to be able to plug into our formula, we need the base area, we need the perimeter, and we need the height. So base area, we've got a rectangle with a side length of 10 feet and a side length of 5 feet. So our base area is just base times height, 10 feet times 5 feet, which is 50 feet squared. Perimeter, 2 times the base, which is 10 feet, plus 2 times the height, 5 feet. Let's see, 2 times 10 is 20, 2 times 5 is 10, so 20 plus 10 is 30 feet. And if you look at your picture, over here we have the height. The height is 4 feet, so h is 4 feet. And then if you plug it into your formula, surface area is 2 times the base area plus perimeter times height. So 2 times 50 feet squared plus the perimeter, which was 30 feet, times the height, which is 4 feet. And if we plug that into our calculator, 2 times 50 times 50 plus 30 times 4, 220. So our surface area, 220 square feet. Example 4. Find the surface area of the triangular prism, round to the nearest whole number. Alright, so again, we need base area, we need perimeter, we need what do you call it, height. Now, if you look here, you'll notice we're missing one of the sides of our triangle. We're missing the hypotenuse. So normally you could do Pythagorean theorem. It'll give you the same answer, but I noticed when looking at it that they're both 8 centimeters, which means if our legs are the same length, we've got a 45, 45, 90 triangle, and the hypotenuse is just the leg times radical 2. So this missing side is 8 radical 2 centimeters. Now, if you go through and do 8 squared plus 8 squared equals c squared, you will end up with 8 radical 2 also. So that now we can find all of our missing information. So our base area, it's a triangle, so our formula is 1/2 base times height. Base is 8 centimeters, height is 8 centimeters. So 1/2 8 centimeters times 8 centimeters, which is, let's see, half of 8 is 4. 4 times 8 is 32 centimeters squared. We need the perimeter of the base, and it's a triangle, so we're just going to add all the sides up. So 8 plus 8 plus 8 radical 2. This is where the round to the nearest whole number comes in, because we've got ourselves a square root. So let's see, we got 8 plus 8 plus 8 radical 2 is going to be 27.31, so to the nearest whole number, 27. So we'll say our perimeter is about 27 centimeters. And then our height from here is 3 centimeters. All right, so now we have all the information we need to plug into our formula. Surface area is 2 times the base area, so 2 times 32 centimeters squared, plus the perimeter times the height, and that's what we're going to plug into our formula, or into our calculator, sorry. 2 times 32 plus 27 times 3, times 3. I got 145. So our surface area for our triangular prism, 145 centimeters squared. All right, so that's your short introduction to prisms and surface area of a prism. Now we're going to move on to cylinders. Let me bring this out so I don't have to write it twice. All right, so a cylinder is a solid that has 2 congruent parallel bases that are circles. So it's similar to a prism in that they're parallel bases. It's just your bases are circles instead of triangles or rectangles or whatever, octagons, whatever you want to call them. So we've got circles for bases. The altitude of the cylinder is a perpendicular segment that joins the planes of the bases. The height of a cylinder is the length of an altitude. So if we look here at the picture I drew, we've got circle bases. They're labeled bases. This here, our perpendicular height, well, that's our altitude, and the height is the length of the altitude. Now, when we're talking about finding lateral area of a cylinder, it's kind of helpful to break up your cylinder into what's called a net to look at it. And you'll notice that if we broke our cylinder apart, you take off the top and the bottom of a Coke can, and you cut it and rolled it out flat, you would have a rectangle for your lateral area, for the area connecting the 2 bases. And so to find that area, we're going to do, let's see, that would be the distance around the circle, or the circumference, times the height. Now, we do have right cylinders and oblique cylinders also. Oblique cylinders look something like that, where they're kind of shifted a little bit to the side, and the height tends to be outside of the cylinder. And so this would be an example of a perpendicular, our perpendicular base, so it's a right cylinder. So our formula for finding the surface area of a right cylinder is surface area is 2b plus 2 pi rh. Now remember, 2 pi r is the formula for circumference, and then h is the height of your cylinder. Now our bases are circles, so we can also write it as surface area is 2 times pi r squared, which is area of a circle, plus 2 pi rh. So 2 pi r squared plus 2 pi rh. B is your base area, r is the radius of the base, and h is the height of the cylinder. All right, so for finding surface area of a cylinder, only thing we need to figure out is our radius and our height. So let's look at example 5. Find the surface area of the cylinder. Give your answer in terms of pi and an approximation rounded to the nearest tenth. So if you look at our figure, we've got a diameter of 3 centimeters. So our radius is half of that. I'm going to put 3 over 2 just because I like fractions. If you want to put 1.5, go for it. Our height is 4 centimeters. Centimeters. All right, so our formula, surface area, 2 pi r squared, so 3 over 2 squared, plus 2 pi r h. Now, if you don't have one of the nice TI-30 calculators that we use in the classroom, you can do this without using the pi button and then plug in pi later. I'll show you what I'm talking about. So we got 2 times 3 over 2 squared is 9 over 2. So that would be 9 over 2 pi. And then 2 times 3 over 2, delete 2, times 4. And that's 12, so 12 pi. And then if you add 12 plus 9 over 2, we get 33 over 2. So our surface area, 33 over 2 pi. Which if you, let's see, if you had used decimals, you should have gotten 16.5 pi. That would have been the same thing. So 33 over 2 pi centimeters squared is our surface area. So that is our exact solution. Our approximation to the nearest tenth, 16.5 pi, is 51.8. So 51.8 centimeters squared is our approximation. Example 6. Find the surface area of the cylinder. Give your answer in terms of pi and an approximation rounded to the nearest tenth. Alright, so you'll notice again we're given a diameter, so we'll do half of that for our radius, so 7 over 2 inches, and then our height is 11 inches, and we're going to plug that into our formula, 2 pi r squared plus 2 pi rh. So surface area is 2 pi r squared plus 2 pi r h. So 2 pi 7 over 2 squared. So 2 times 7 over 2 squared is 49 over 2. 49 over 2 pi plus 2 times 7 over 2 times 11 is 77. So 77 pi. So 49 over 2 plus 77 is 203 over 2 pi inches squared. And if you did that with decimals, that would be 101.5 pi for your exact solution. And so our approximation, let's see, 101.5 pi is approximately 318.9. 318.9 inches squared is our surface area for our cylinder. All right, 7, nice word problem for you. Standing 82 feet tall with a radius of approximately 11 feet, the Aquadom is located in the Radisson Hotel in Berlin, Germany, and is titled the world's largest cylindrical fish tank. Find the surface area of this tank without the area of the top base. Find the exact surface area and an approximate area rounded to the nearest tenth. So the only thing that's different with this one is our fish tank doesn't have a lid. So instead of having 2 bases in our formula, we're just going to have one base. So instead of 2 pi r squared, it's just going to be pi r squared. So we know our radius is 11 feet, approximately, and the height is 82 feet. So our surface area, one base, so pi r squared, and then our lateral area, 2 pi r h. So 11 squared is 101, so 121, so 121 pi plus, let's see, 2 times 11 times 82 is 1804 pi. So add those together, and our surface area, exact solution is 1,925 pi, and that's feet squared. All right, and so our exact solution, and then our approximate solution to the nearest tenth, 1925 pi, is 6,047.6 feet squared. All right, example 8. So the only reason I'm doing example 8 is that it's very similar to one of the problems in your homework assignment. It actually does a lot more than what's in your homework assignment. So I will point out exactly the part that you're going to need for the homework example, or for the homework. So part A, you'll notice we've got ourselves a rectangular prism in 3D space. So we've got X on this axis, we've got Y on this axis, and then Z on the vertical axis. So when we're writing coordinates, we have to use 3 numbers, and we do them in X, Y, Z order, just like if we were writing an ordered pair, X, Y. So an ordered triple is X, Y, Z. So let's start with the vertex A, which is right here. So on the x-axis, we go out to 4. We didn't go anywhere on the y-axis, so it's 0. And we didn't go anywhere on the z-axis, so it's also 0. So the coordinate for point A is 4, 0, 0. For B, which is right here, we went 4 on the x-axis. The y-axis we went 1, 2, 3, 4, 5, so 5, but we didn't go vertically, either up or down, so that's 0. So 4, 5, 0 is our area, or is our point. Or is it 3? 1, 2. Oh, that should be 3. These should be 3s. I'm sorry. I was a little distracted. Okay, so yeah, that's at 3. I saw that 4 and I thought it was for that, but no, 4 is right there. Okay, sorry about that. C, right here. We didn't go anywhere this way, so nowhere on the x-axis. We went out to 5 on the y-axis, and we didn't go vertically, so 0. So 0, 5, 0 for point C. And point D, which is up here, we went, let's see, we didn't go this way, so 0 for x. We went out here for 5 for y, and then we went up to 4, that's that 4 right there, for z. So 0, 5, 4. So that's just a quick introduction to 3D points. That's not part you need to know for the homework assignment, so you're good. B says to find AB. So we're looking for the length of AB. So we went from 0 to 5, so this length is 5. So AB equals 5. Luckily, since this is a rectangular prism, all we got to do is count. We don't have to do any sort of distance formula or anything, which is very nice. BC, this length here, we go from 0 to 3, so it's 3 units long. So BC is 3. CD is right here, so we went from 0 to 4, so it's 4 units long. So that's 4. So now we know the base, we can find the base area, and we have the height. All right, so the part that you're going to be asked to do in the homework is finding the area of one of these sides. So you'll need to be able to find these lengths to do it, which is what we did in B, C, and D. So the first one wants the area of AGCB. So face AGCB is this bottom part of our prism. So base times height is 5 times 3. Which is 15, we'll say units squared, because it doesn't give us a unit of measurement. F wants the area of BCDE. BCDE is this side of our figure. So base times height, because it's a rectangle. So 3 times 4 is 12 units squared. And G wants the area of ABEF, which is 5 and 4. 5 times 4 is 20 units. So those are the areas of our faces, and that's the part that you'll be asked to do in the homework, is find the area of a face. So part H wants you to find the surface area of the entire thing. Well, we have for AG was down, that was this one here. We've got 2 of those because they're parallel. So we can do 2 times that. We have 2 of these sides that are congruent, so 2 of those. And then we have 2 of these faces, the front and the back, so 2 of those. So that's 30, well, 2 times 15 plus 2 times 12 plus 2 times 20 is 94. So the surface area, is that right? Because I have something different on my paper. 15, 12, and 20. So 40 plus 30 is 70. Wait. And then 24 is 94. So 94 units squared is our surface area. But this is what you're going to need for the homework. And they're just going to ask you for one side. They're not going to ask you for all 3. So it won't be as much work as this whole problem was. All right, so remember, I've got office hours Monday through Friday, 9:30 a.m. to 10 a.m. This is the link to the Zoom meeting in the Google Classroom. And then you can also contact me via email or Snapchat if you have any questions.